Students, welcome to part 2 on the rectangular approximations integration review. So let's go ahead and consider the following question. In the previous clip, we did left-hand endpoint rectangular approximation. In this example, we're going to be looking at midpoint, okay? Midpoint or rectangular approximation. So let's take a look at the question. This is number 2. So let's do the following. Use MRAM. MRAM is also known as midpoint rectangular approximation to estimate the area under the curve of the equation y equals x to the third minus 2x squared plus 5x plus 5 on the interval -1 to 3 using 4 subintervals. Okay, and we expect it to include a sketch. Alright, so for this one, what we're going to do first, before I generate the table of values and then the curve, let's review what MRAM, LRAM, and RRAM are. Okay, so let's consider these three curves. They're exactly the same. So let's start with LRAM, left-hand rectangular approximation. Let's say we're using 4 intervals for all the cases. We're going to be using 4 intervals. On the interval, -1 to 3, just like the question indicated. Okay, so this is what we're going to be using. So let's look at LRAM. What if I wanted to do LRAM on this graph, starting from -1 all the way to 3, using left-hand rectangular approximation. Now to do that, all you just have to notice that we're going to divvy up our intervals into 4. So this is 1. So this is 1, 2, 3, 4. So these are 4 intervals. So what we're going to do here is we're going to start with the left point, then we're going to pick 4 tick marks, and that's what we're going to use to construct our graph. Okay, so this is the leftmost point. We're going to trace it up to the graph. So there goes 1, and this is another one, another point right here, and then this is another one, 3, and 4. Now you see these 4 points I graph, 1, 2, 3, 4. Those are the heights of my rectangles. Okay, so let me draw them in for you so you can see what I'm talking about. So the first rectangle goes like this. You see how it started from this left endpoint from 1, a little bit too far to the right. And then my next rectangle is going to be f of 0, starting from here, extended straight up. You see just the left endpoint is what you trace to the curve and then you formulate a rectangle. Okay, then this one right here is like this, the left endpoint. That's rectangle number 3 or interval 3. And then the last one, left endpoint touching there and spanning the entire width. Okay, so this is what the left endpoint rectangular approximation looks like. So we start with the left endpoint and trace it to the graph 1, 2, 3, 4 because we're using 4 intervals. Okay, so this is LRAM, and the area of this rectangle is basically the approximation of the area under the curve. The more rectangles you use or the more intervals you have, the closer your area is to the actual area under the curve. Okay, and at infinity you basically have the exact area. Now let's try the right-hand rectangle approximation, right-hand endpoint rectangle approximation, and then we will look at the midpoint. Okay, so we're going from 1 to 3, so we need 4 intervals, right? So if I go 1, 2, 3, 4, there goes my 4 intervals. So let's see, how do we sketch this? Instead of using the left, we're going to start from the right side and we're going to go all the way to the left, 4. Okay, so this will be the first one. 1, 2, 3, 4. Okay, so these 4 points determine the height of my rectangle. So these I started from the right, 1, 2, 3, 4, because we're using 4 intervals, and I didn't pick the last one. And if you notice in this case, the LRAM I started from my left, 1, 2, 3, 4, and I didn't use the last one. That's always the case. Okay, for LRAM, you leave out the last one on the right, and then for RRAM, you leave out the last one on the left. Okay, so let's create what our rectangles will look like. So I start from the rightmost point, and I go straight to my graph, and then formulate a rectangle with the width of 1, because when I break up my intervals into 4, the width of each rectangle is 1, okay? And then the next one goes here. Notice how it's the right endpoint that's touching the curve. Okay, and then the next one, a little bit. And then the last one goes like that, okay? So that's our rectangular approximation with 4 intervals from -1 all the way to 3, okay? Alright, now how about the midpoint rectangular approximation? Remember, all we're focusing on here is just how to sketch it, okay? I'm going to do the calculus of the computations in a minute, but I just want to show you how to generate the curve. Alright, so we do midpoint rectangular approximation from -1 all the way to 3, 1, 2, 3, 4. But we're using the midpoint. This one's a little bit technical to draw. So we have 4 intervals, right? So within our 4 intervals, we're going to use the middle of the 4. Okay, so this is interval 1, 2, 3, 4. We're using neither the left nor the right, we're using the middle. So this one going up right here, wherever the midpoint touches the curve, that determines the height of the rectangle. So that's the first rectangle. The second one is in the middle of this interval right here. And then the third interval is between 1 and 2. The middle is right here, right on the curve, and then the last one, 2.5, is right there. Okay? So MRAM, you have to use the midpoint to determine the height. Trace the midpoint between the intervals to the curve, and that determines the height. Okay? Alright, let's draw in the rectangles to show you how it looks like. Yeah? See how it's the midpoint that determines the height, where the midpoint touches the curve. And the next one, like that. The width of the rectangle is uniform across each problem. The width is basically 1 unit. Okay? Alright, and then the next one, do that again, like this. That's rectangle number 3. And then the fourth one, you notice is where the midpoint hits the graph, that's what determines the height of my rectangle. Okay? And that's basically MRAM for you, midpoint rectangular approximation. Okay? Alright, so with this review in mind, let's go ahead and consider the question that we introduced earlier. And let's see how we can do it, okay? So we're asked to include a sketch in this problem. So in order to sketch the curve, we're going to make use of a table of values, alright? Now the assumption here is we do not have a calculator, so we're going to have to do everything by hand. Alright, let's do it. So we're going to start with a table, generate a table of values, and then use it to sketch our curve, okay? Alright, so let's see. X, and then my output is defined by y equals x to the third minus 2x squared plus 5. Okay? We're starting from -1 all the way to 3. I want to graph the point, so let's start with -1. If I plug in -1 into this function, I'll have y equals -1 to the third minus 2 times -1 squared plus 5. Okay? Simplifying that, -1 to the third is -1. Minus 1 squared is +1. -2 is minus 2 plus 5. We have -3 plus 5 is 2. Okay? So our output for the input of x equals -1 is 2. Alright, that's what y is. Okay, moving along. Now let's input the next x value, which is, let's go for 0. I'm going to use integers here. So for 0, we're going to have y equals 0 cubed minus 2 times 0 squared plus 5. Okay? So for this out, we're going to have 0 minus 0 squared, 0 times 2 is 0 plus 5 equals 5. Alright, so output here is 5. Next one is this, let's plug in 1 and see what our output is going to be. So if I plug in 1, output is going to be y equals 1 to the third minus 2 times 1 squared plus 5. 1 to the third is 1. 1 squared is 1 times 2 is 2. plus 5. So this is negative 1 plus 5 is 4. The output here is 4. Okay. We have 2 more outputs to generate. So the next one we're going to generate is 2, and then we'll generate 3. Okay. Alright, so for output number 2, we're going to have, for input number 2, we're going to have y equals 2 to the third minus 2 times 2 squared plus 5. Okay? 2 to the third is 8. 8 minus 2 squared is 4 times 2, 8 plus 5. 8 minus 8 is 0, plus 5 is 5. So our output here is 5. And then last but not the least, we're going to use 3. Okay? So we'll plug in 3, calculate the output. We have y equals 3 to the third minus 2 times 3 to the third plus 5. That's going to give us 27 minus 3 squared. Oh boy, this is 6 squared right here. 3 squared is 9. 9 times 2 is 18 plus 5. And if you work that out, you get 14. Okay, so our output here is 14. Alright, so we have all the values to generate our curve. Let's go ahead and sketch what the graph looks like. Then I'll give you a visual about what MRAM looks like, and it will calculate what the value is, the approximate area. Okay? Alright, so that goes our coordinate system. I'm going to use 4 boxes for a unit here. Hopefully we have enough space. Let's see. This could be 1, 2, 3, 4. Hold that 1. Negative 1. 1, 2, 3, 4. Hold that 1. 1, 2, 3, 4. Pull that 2. 1, 2, 3, 4. Pull that 3. 1, 2, 3, 4. Pull that 4. Okay? Alright, let's go ahead and graph the points. So for negative 1, it goes up to 2. So this is, I'm just going to go by units on my y-axis. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, because that's the highest value I have here, 14, okay? Alright, so for negative 1 trace goes out to 2, take 1 to 2, first point. And then 0 goes to 5, 0, 1, 2, 3, 4, 5. And then 1 goes to 4, 1, 2, 3, 4. 2 goes to 5, 1, 2, 3, 4, 5. So it's kind of like a cubic function. Well, it actually is a cubic function. And then 3 goes to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, way up here. Alright, let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, excellent. Alright, let's sketch our curve. Remember, this is just a sketch, okay? So it's going to look something like this. Let's see there. Curves there. Uh-oh. Like this, and then curves to there, and then goes up, up, up to that point, and extends up. Okay. All right. So for this graph, we're going to be doing the midpoint rectangle approximation. This is just a sketch, but our rectangles would be more exact. Okay. So what will the midpoint rectangle approximation look like? We're using 4 intervals, so our intervals is going to start from, we're going to have negative 1 to 0, that's the first interval, to 1, 2, to 2, 3, to 3, 4. So there goes the 4 intervals. Since we use a midpoint, we're going to be using the middle. Okay, so between negative 1 and 0 is 1/2. I'm sorry, negative 1/2. Okay, so we're going to trace that to the curve, right there. That's the first midpoint we're going to be using, and then between 0 and 1, the midpoint is 1/2, positive 1/2, right there. And then between 1 and 2, the midpoint is 3/2, 1.5, so trace that there. And then the last one between 2 and 3, which is 2.5 or 5/2, this is 5/2, it's going to be right here, okay? Alright, so these points I graphed determine the height of each rectangle, okay? Because that's a midpoint. Alright, so let's go ahead and sketch the rectangle. So starting from here, there like that, there goes the first one. And then the second one, notice where the point hits the graph, that's what determines the height. And then the third, I'm making spaces here. Let's make this a little bit wider. Let's see. Maybe it's a little bit wider so it fits in perfectly. Alright, and then the next one, see the height right here, exactly where the point hits the graph that determines the height of my triangle. There goes the third one. And then the fourth one goes right there. Okay. Now all we're doing next is we're just adding the area of each rectangle. Okay. Notice they all have uniform width. The uniform width of my rectangles are 1. So from here to here, from here to here is just this is just 1. For all of them, the width is 1. Okay. So basically, the height times 1, or just the height, will determine the area of the rectangle. Okay. So what's the height of this rectangle? The height of this rectangle, this value right here, is going to be f of 1/2, negative 1/2. This will be f of 1/2, f of 3/2, and f of 5/2. That's going to determine the height. Okay. All right. So let me write it in equation form for you. So let me write it down here. The midpoint rectangular approximation is going to be 1 times f of negative 1/2. This is the area of rectangle number 1. 1 times f of 1/2, negative 1/2, that's the height, plus 1 times f of the next rectangle. To find the height, I'll plug in 1/2 into the function. And then plus 1 times, the next one is 3/2 to find the height of the third rectangle, f of 3/3 plus 1 times 5/2 is what I'll input into the function to find the height of the fourth triangle. Okay, so this is area of rectangle 1, rectangle 2, rectangle 3, rectangle 4. Okay, so if I find out all these values of this output values of these functions, that I'll just add them together, and that will give me my area. Okay, so let's go ahead and compute what these values are. Remember, the assumption here is we do not have a calculator. With a calculator, you can do this in a snap. Okay, so we just sharpening our arithmetic skills here by calculating these values by hand. Okay, so remember, f of x is going to be x to the third minus 2x squared plus 5. F of x and y are the same thing. Okay, so don't get confused with the symbology. All right, f of negative 1/2. To calculate that, we just plug in negative 1/2 into the function. So we have negative 1/2 to the third minus 2 times negative 1/2 squared plus 5. Okay. All right, let's work this out. Using order of operations, if I cube this, since it's negative, it's still a negative, negative 1/8 minus 2 times the square negative is a positive, 2 times 1/4 plus 5. Okay. And this becomes negative 1a minus 2 goes here 1, 2 goes here 2, minus 1/2 plus 5. Write this as a fraction. To combine this, I need the LCD of 8, so I times this by 4. Top and bottom times this by 8, top and bottom. So that gives me minus 1 minus 4 is minus 5, minus 5 plus 40 is positive 35, so it's 35/8. Okay. All right, next one is f of 1/2. It's going to be 1/2 to the third minus 2 times 1/2 squared plus 5. Okay. All right, let's calculate that. 1/2 to the third is just positive 1/8 minus 2 times 1/2 squared is 1/4. We square the top and the bottom plus 5. Okay. All right, now I can reduce this. 2 goes here 1, 2 goes here 2. So that gives us 1a minus 1/2 plus 5. Let's write this as a fraction. We need to make the denominators the same, so I need to times this by 4 because the LCD is 8. Times this by 8 top and bottom. Alright, the denominator is going to be 8, so let's focus on the top. 1 minus 4 is negative 3. Negative 3 plus 40 is 37. Okay? So there goes the height of the second rectangle. In third rectangle, we're going to do f of 3 over 2, which is 3 over 2 to the third, minus 2 times 3 over 2 squared, plus 5. If you cube this, you're going to end up with 3 cubed is 27, 2 cubed is 8, minus 2 times 3 squared is 9, over 2 squared, which is 4, plus 5. Okay? Simplify this, 2 goes here, 1, 2 goes here, 2. So you're going to have 27 over 8, minus 9 over 2, plus 5. Okay, let's make this over 1. Okay, so to add these fractions, we need the same denominator, so I times this by 4 top and bottom. And then this one I times by 8 top and bottom, okay? Alright, so since we have the same denominator, namely 8, we just focus on the top. Negative 27 minus 36 plus 40 is going to give us 31. Okay? 31. Alright, now let's move on to last but not the least, to find the height of the fourth rectangle. F of 5 over 2 equals 5 over 2 squared, plugging in 5 over 2 into x of the original function times 2 over 5 over 2. Actually, this is to the third, and this is 5 over 2 squared plus 5. Okay? Alright, we're getting this out. 5 to the third is 125, 2 to the third is 8, minus 2 times 5 squared is 25 over 4, plus 5. Simplify this, 2 goes here, 1, 2 goes here, 2. That becomes 125 over 8, minus 25 over 2, plus 5. Let's write this as a fraction also. So to find the LCD of 8 to 1 is 8, so maybe this times it by 4, top and bottom, and times it by 8, top and bottom. Okay? So now we're going to have, if you do the calculations, 125 minus 100 plus 40 comes out to 65 over 8. Okay? Alright, so basically our midpoint rectangle approximation is going to be 1 times 35 over 8 plus 1 times 31 over 1 times 31 over 8 plus, actually this one was 37, the second one was 37 over 8. Let's look at what we have. We have 37 over 8 is the second one, so 1 times 37 over 8 plus 1 times 31 over 8 plus 1 times 65 over 8. Okay? So if you add them all up together, let's see what we get. Okay, so we can add them up. If we add them all together, we get 168 over 8. And then just divided by 8, you end up with 21. Okay? So MRAM in this case, midpoint rectangle approximation, is 21. Alright? So there you have it. Thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking up here, so you can get updates to other cool clips to in the completion of this integration review video series. Okay? More videos coming from microserve.com. Thanks again and have a wonderful day.